Alright guys, so now we're going to actually start solving exponential functions with logarithms. The reason why we use logarithms when we're looking for exponential functions is because the answer we get when we take a log actually is an exponent. So as you look at this problem, e to the power of x minus 3 and 2 to the power of 3x, we notice that our variable is in our exponent. So we have to have some sort of operator that when we solve it will give us an exponent for an answer, and that's what logarithms are. Now we have a lot of different choices. You can really pick any base you want as far as logs go. The obvious choices here would either be A, your common log, because that's base 10 and that's already built into your calculator. You could always do log base 2 because here 2 is your base of this exponential equation. And of course log base 2 of 2 would equal 1. Or over here, e is my base raised to the power of x minus 3, so I can actually do log base e, which is the natural log. Now I use log base e simply because I'm lazy and it's 2 letters versus 3 letters or maybe 4 letters. Really is the only reason why I use ln's, because it's easier to write, it's faster to write it, because it's 2 letters versus 3 or 4. I'm really not joking, guys. So I'm going to ln both sides. So I'm going to get ln e to the x minus 3 equals ln of 2 to the power of 3x. Now, of course, when we're expanding and contracting, we know where to put these exponents. They come down in front. When I do that, I get x minus 3 times ln e equals 3x times ln 2. Now, of course, ln of e is just 1, so that leaves me x minus 3 equals 3x ln 2. Now, I'm going to put all my variables on one side, all my constants on the other. When I do that, using just basic algebra, this is positive over here, so I can act like I'm subtracting it. So I'm going to have x minus 3x ln 2 equals, and of course I'll move my constant, this constant here, over here, so I'm subtracting, so I'm going to add, it equals 3. Now if you notice, if you look at each of your terms here, they now have an x in it, so you can actually factor that out. So I'm going to factor this x out and this x out, and when I do that, I'm dividing by x, because I'm going to be multiplying by x, so we need to make sure that we don't change the equation. So I'm going to get x times 1 minus 3 ln of 2 equals 3. Good times. From here, this is just x times all of this number. This is just a number. Even though it looks horrible, it's just a number. So we're just going to divide by it. So we're going to get x equals 3 divided by 1 minus 3 ln 2. From there, we solve for x. If I wanted the exact answer, that's pretty much you're done at that point. But if I want an approximate answer, this is going to be approximately negative 2.78. Not too bad. Really is not that bad. Now, let's look at a nice fun one. I could give you a problem such as e to the power of 2x minus 4e minus 5 equals 0. And this is e to the x, I'm sorry. And I'm going to ask you to solve for x. Well, first off, we see our x is in the exponent, so we know we're going to have logs somewhere, because of course logs, the answers give us an actual exponent. We have to go back to trig. When I showed you all the trick of u substitution, I want to pick e to the power of x for my u. So I'm going to go ahead and say let u equal e to the power of x. Now you don't have to do this, but it's going to make it look a lot simpler. So everywhere there's an e to the x, I can replace it with a u. So we're going to end up with u squared minus 4u minus 5 equals 0. Now I know you guys can factor this, but as I said in my class, we'll only ever use the AC method of factoring. So a times c, my a is 1, my c is negative 5. When we multiply those, that is negative 5. My prime factors of negative 5 is plus or minus 1. Well, my factors of 5 are plus or minus 1, plus or minus 5. I'll look for the combination where I can rewrite my middle term, which is negative 4. That's going to be a negative 5 and a positive 1. So we rewrite my middle term. So we're going to have u squared. So I'm going to rewrite this term here, negative 4, as plus negative 5 u plus u. And of course I bring down my minus 5. So I just rewrite that middle term because of course negative 5 plus u is still negative 4u. I did not change the equation. Now we're going to group. We're going to group the first two together and the second two together. And you want to make sure you have a plus in the middle. This is why I always say you want to add negative numbers so you don't mess your signs up. When we do this, we're going to factor out the GCF of each group. U squared and a negative 5u has u in common, and that will leave us u minus 5. And of course, that is what this is right here. So we have plus 1 u minus 5. Therefore, my factors are u plus 1 and u minus 5, and we are fully factored. And of course, all these equaled 0. Now from here, we go back to algebra 1. Well, really algebra 1 or algebra 2. We're going to set both factors equal to 0. So we're going to have u plus 1 equals 0, and u minus 5 equals 0. Solve for u, we get u equals negative 1, and of course u equals 5. Now we're going to back substitute. My u equals e to the power of x. Therefore I have e to the power of x equals negative 1, and e to the power of x equals 5. Well, if I ln both sides here, I'm going to get ln e to the power of x equals ln of negative 1. That's a problem. This number right here has to be greater than 0. It doesn't. So this is going to be an extraneous answer. It's not an actual real solution. But on this side, if I ln both sides, I get ln e to the power of x equals ln of 5. Of course, this x can come in front. So now I have x ln e equals ln 5. ln e is just 1. Therefore, my x equals ln 5. That wasn't too bad. It's a lot of fun, really. Remember, guys, on these videos, I know I went a little fast on this. Pause is your friend. You can pause it, rewind it, fast forward it to what you need. Next activity, what we're going to be getting into is transformation of different functions with different parent graphs. And this will be really fun because for the first time you'll have to do transformations without a graphing calculator.